Hi, my name is Reagan Bremmett, and today I'm going to be explaining how our bodies turn one molecule of ATP into 30 ATP. This is basically how we get energy from sugar. It might sound complicated, but I am going to go through the steps so it makes more sense, and I hope you enjoy my presentation. Thank you. For my first slide, we're going to talk about the overview of cellular respiration. The whole thing starts with glycolysis, and this is where glucose gets broken down into pyruvate molecules. Pyruvate then moves into the mitochondria. This is where it turns into acetyl-CoA. That acetyl-CoA goes into the citric acid cycle, and from there we collect NADH and FADH2, which are used in oxidative phosphorylation. And that's actually where most of the ATP is made. You can see in my diagram how the energy flows from glucose all the way through the process using the arrows and color-coded steps from the book. First, we're going to start off with glycolysis. Glycolysis happens in the cytoplasm. We actually spend two ATP in the beginning. One is used by hexokinase and the other by phosphofructokinase 1, but then we make some back. The enzyme G3P dehydrogenase creates 2 NADH, which gives us 5 ATP later on. And we also make 4 ATP through phosphoglycanase and pyruvate kinase. So when you do the math, we actually end up with 2 net ATP and 2 NADH. This adds up to about 7 ATP total. This is all from my diagram, which shows how other sugars like galactose or fructose can jump into glycolysis at different points, but all ends the same way, with pyruvate. Once we have pyruvate, it heads into the mitochondrial matrix. There, the pyruvate dehydrogenase complex, which includes the 3 enzymes E1, E2, and E3, converts each of the pyruvates into acetyl-CoA. This step releases carbon dioxide, and for each glucose, we get about 2 NADH, which equals to about 5 ATP later on. This step doesn't really make any ATP directly, but it is very important because it shows how carbon from glucose actually enters the Krebs cycle, otherwise known as the citric acid cycle. Going right into the next slide, we have the citric acid cycle. This is where most of the energy, or ATP, is made. Since each glucose gives us 2 acetyl-CoA molecules, the cycle goes around twice. We get 6 NADH in total, 2 from the isocitrate dehydrogenase, 2 from the A-ketoglutarate dehydrogenase, and 2 from the malate dehydrogenase. That's worth about 15 ATP, and we also get 2 FADH2 from the succinate dehydrogenase. That's 3 ATP. And then 2 directly from GTP made by succinyl-CoA synthetase. So altogether, the citric acid cycle gives us about 20 ATP. For my summary of everything, how we went to 1 ATP to 30 ATP, I made a chart including all my information. From glycolysis, we get 2 ATP and 2 NADH, which is 7 ATP total. From pyruvate to acetyl-CoA, we get 2 NADH and 5 ATP. And from the citric acid cycle, we get about 6 NADH, 2 FADH2, and 2 ATP. And this gives us 20 ATP. Adding it up together, it's 30 ATP from just 1 glucose. Thank you for listening to my presentation. I hope you have a great day.